This video will cover the geometry Regents exam from June 2015, questions 35 through 37. Number 38 is the one 6-point question that you have here on this old Regents exam. It says the diagram below shows square ABCD where E and F are points on BC such that BE is congruent to FC. Prove that AF is congruent to DE. So we want this piece to be congruent to this piece. So it looks like in order to do that, I need to prove triangle BFA needs to be congruent to triangle CED because we want AF to be congruent to DE. So again, I'm just going to write need triangle ABF congruent to triangle DCE. So I'm going to set up my T-chart for the proof here. I'm actually going to zoom out on this so we can see the picture and the proof at the same time. Hopefully I don't write too big. Okay. Oh, maybe this won't work the way I wanted it to. So we've got this T-chart going. Left side is always for statements. Right side is for reasons. Up here at the top, you actually need to write this entire thing for the given. I'm not going to write it now. I'm just going to skip that one step because of space. But you would, again, need to write that entire thing. Now, in order to get triangles congruent, we can prove them in one of 5 ways. We can use SAS, ASA, AAS, SSS, or HL. Now, HL can only be used with right triangles, where you have a hypotenuse and a leg. So because of the fact that we have a square, we can actually state that angle B is congruent to angle C. And if you're looking at this, the square, of course, has right angles. So we're going to say a square has 4 congruent right angles. Okay, so that's one step. Now we also know that the 4 sides of a square are congruent. So I'm going to mark AB congruent to DC. So I'm going to state that AB is congruent to DC. And this is because a square has 4 congruent sides. Alright, so that's 2 pieces of information. Now, for the third one, I might try to use something regarding this top segment, BC, except that I know that BE is congruent to FC. And EF is kind of stuck there in the middle. In the end, I need BF. So if I have BE plus EF, that would give me that whole segment. I also need EC. So if I have FC and EF, that would then give me EC. So what I'm going to do is state that EF is congruent to itself. And that's by the reflexive property. So if I move this up just a little bit. If EF is congruent to EF, that would allow me to state that BF is congruent to CE. And this is because of the addition property. I'm taking a part plus another part and getting a whole. Part plus part gives you whole is addition, you're adding. Which means that I can mark this up now. So if I look back at my picture and mark it up with S's and A's, we have a side, an angle, and a side. Which means that the 2 triangles we had are congruent. Triangle ABF is congruent to triangle DCE. Side, angle, side. So then number 7, we're able to prove that AF is congruent to DE by a reason that's abbreviated as CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. C, P, C, T, C. A way that you could remember this is 3 C's separated by a PT, part-time. I have no idea where the part-time comes into play here at all, except for the fact that it uses the letters P and T. So now our proof is complete.